Today is Saturday, June 10th, 2023. And today, we're going to see if Chatgpt can make us some LEDs.
So we go to the place and we give it a prompt. Hello, chatbot. You are a developer for an embedded systems. I need you to design an RGB controller code for Arduino IDE. I need you to use the Adafruit Neopixel library. Please construct code for an ATtiny85 that is a string of 7 Neopixel LEDs and 2 momentary push buttons for input. Please produce the code. And it's doing it. All right, great. Let's get our parts.
ATtiny85. Some spare circuit board. A string of 7 Neopixels. 2 push buttons. Some wires and things. And some headers. Well, let's put it together. So we're going to be using pin 0, 1, and 2. 0 and 1 are going to be for the push buttons. And I want the push buttons to be for brightness and for color. Not exactly sure how that'll kind of flesh out. Maybe keep pressing it, it'll change the brightness. Keep pressing the other one, it'll change the color. So we're going to need to connect those to one of those pins. And then obviously pin 2 to the data pin, which is the center pin on here. I got a little right angle header for that. Got a little piece of proto board. I've just stuffed the headers right through. So we're gonna wire these together. Just gonna solder these together real quick. It's pine time. Wait, no, this is pine sill. This is pine time. All right, yeah, we're gonna solder things now. What do we got? 3. All right, that should be good. I went frisbee golfing today at the park down the road for the first time. It was great, and all the smoke from Canada has gone away finally, so you can go back outside. I don't know what it's like for you Western states folks who deal with that all the time, but good riddance. It's terrible. All right. So we're soldered up here. Good enough for government work. Not that I work for the government. You even have 3 extra pins, just in case we feel like doing something in the futures. So the plan is, when you plug this in to the USB drive, the orientation of it is such that it's going to be, call it upside down like this. So I'm going to put the buttons on the top side. And to make it easier on myself, because pin 0 and 1 are going to be for the buttonness, I'm going to put one button. Let's see, pin 0. I'm going to put one button here. And actually, I'm going to move it back and over just one. So we're going to connect the pin to there and to, I believe it's got to give it ground. Yeah, I think we got to give it ground access. And then the other one for pin 1. So we'll do pin 1 here, pin 2 here, and then the other one will pin, pin, let me point at what I'm talking about. This is pin 0. Pin 0 is going to go to button 1. Pin 1 is going to go to button 2. Pin 2 is going to go to the header for our arguable LEDs. I just want to stuff this through somewhere. Yeah, right there is fine. And then we'll solder that. Let me just check that these directions for the continuitables are in the right orientation so that I can do what I want. Okay, so it's going to go across. I'll push the button. All right, so I got to give, let's say the top pin here the ground, and then the same thing, the top, the bottom pin, the ground. So we're gonna have some little itty bitty wires here. Is there a different way we could lay this out instead? Let me think about it for a second. Okay, I thought about it for a hot second. I just rotated these. So now this is the ground pin, and it's going to go into this pin, and then this pin is going to go over to this pin right here. So when I push the button, it's going to complete a circuit in this direction. And so here is the, see, it makes beeping noises, and when I touch the pins, nothing happens, but when I press the button, it does the thing. And the same thing over here. I'm going to get a ground, I'm going to loop it over to here, and it's going to go through the button and then into pin 0. So pin 0 and pin 1 are just going to be across like that, and then pin 3, or pin 2, it's just going to come around to our ergable header. And then I had a servo wire, and I wasn't really pleased with the pin wiring, so all I did was just flip up the, I put the white wire in the middle. So it's just as simple as repinning it. So you just kind of flick back the little plastic choochers. Oh, you got to get them both up. I guess we'll do one at a time. Get you up. And then it should just slide out. And then the same for its neighbor. I mean, the wire would work fine, but just for the clarity of ground is on the outside, data is in the middle. Power and ground is on the outside. And then you just push that back. Great. Now I have a properly keyed jumper cable. And then I'm going to put this about right here so that when it's plugged into the computer, this side is down. The wire is going to come from right here to plug into our Ergerburgles. Gerblers. All right, let's solder. I guess first we should wire up some power and ground to the places that need them. Just make up some wires. Oopsie, I should have waited to solder that board to the other board. So I just made like a little T-pin thingy bob doodly hoo, and that's gonna sit carefully like right there, and then this'll connect. So it's just gonna be a little bit difficult to solder because I can't get underneath there anymore. So I'm just gonna do a line across from there, get that in, and solder that in. Before I solder that, let's confirm that ground is the right thing to do. I believe that we can use an internal pull-up on here, but I just need to double check that.
Okay, according to ArduinoSlovakia.eu, yes, and supposedly it has an internal pull-up resistor that we can use, which just so happens to be the code that was generated exactly the same. Pin mode button input pull-up, button input pull-up. Yeah!
There we go. Should be ready to plug it in and give it a program.
All right, over on the Confuser, I found starting electronics for beginners, and what we got to do is paste in the JSON location for the DigiStump, which these are DigiSpark clones of the AT-95 with a magical USB doodly-doo on it. So you got to put that in, and once that's in, you can go to Board Manager and you can type in DigiSpark. Makes you wonder, like, what will happen in the future when you want to do this stuff and like it's just not available. How do you keep it? You got to keep an old computer with like Windows XP on it, and then you need the drivers for it. So you gotta trust that these zip files of whatever it is not gonna like do anything terrible to your computer. You're just trusting. You're trusting this, you know? I should extract it first. But, you know, like, who knows what's on here? Oh, Windows is not happy. Oh, it's totally fine with it. Wonderful. We just installed the 2014 driver, and now we're good to go. And then finally, from the DigiStump menu in the board, select DigiSpark default 16.5. And we just copied the code. So it already said in here, please note that the code assumes the push buttons 0 and 1 are there. And this code allows you to cycle through different colors and brightness levels using the push buttons. So it kind of just figured out that's what I would want to use those buttons for, which is, thank you, Chatgpt. So let's click upload and see what happens. All right, well, it programmed. Micronucleus said thank you, so I'm assuming it's done. So now we just need to plug in the right pins. So the ground goes there. So this, if this works, we'll find out. You know, we're gonna plug it. We're gonna plug it in. We're gonna see what happens. Chatgpt and Arduino. Wow. Okay, it's got some kind of pattern on it. What do the buttons do? So it's constantly cycling the brightness. I have a feeling there might be some wiring thing. But the color seems to change each time I click the button. But this button, something might be up with that button. So let's double check our code and the buttons. I guess let's look at the code first. Pin 1, which is 0, pin 1, pin mode, pin 1. Change color. Okay, so pin 1, that's the one that changed to the color. That one works fine. Pin 2 on pin 1 is change brightness. So it's calling the change brightness function. So when the button is pressed, it increments the brightness level by 32. And if it's still, when it gets to be greater than 255, then set it equal to 32. So it's going to go 32 plus 32 plus 32 plus 32 plus 32 plus 32 plus 32. It's going to get hit to 224. It'll get to 256, and then it'll immediately set it to 32, because obviously it can't handle those numbers. So I'm wondering what the problem with this could be with the brightness, because we saw when we plug it in, it just cycles the brightness up and down. It doesn't actually let us press the button. See how it's automatically cycling it? And that delay in there is probably the 200 millisecond in there. So it's like as if that button is constantly being pressed down. Let's go check our circuit. Okay. We got the thing in the thing mode. Let me just check this button. Make sure this button is... So that's appropriately doing the ding. Ground there, 5 volts there, ground there. Let's go shoot, shoot, shoot. Shoot, shoot, shoot. Make sure there's nothing anywhere else. All right, let's try it again. It's still doing, but it does change colors. So let's look at the code again and just try and understand how it works. So when the thing that does work is that in the loop, it reads the buttons and the change color function is being called. Every time you click the button, increment the number. Oh, so this is going to cycle 1 through 6. Okay. And then it's going to go and call color LED after that. Each function in here, it does a 0, a brightness level, and a 0. And it has 6 different stages for the 6 different colors. And the way that this works is that the strip.setPixelColor is expecting N for the number of LEDs, a red, a green, and a blue value. And so it's saying for I, it's going to say 0 through 6, give me 6 different predetermined colors that you're going to use. And so for the first one, it's going to do brightness level 0, 0. So in this case, red is the brightness level and 0, 0. So that means it's going to just say, make it red. And then the next one is going to be make it green. The next one is going to be make it blue. And then on this one, it mixes together some colors. So it's going to be the red and the green because they're in the positions red and green, and the blue is 0. So between red and green, we get a yellow color. And the same, and so on and so forth. So we get a yellow, we get a purple, and we get a cyan, and we get a white because it's got all the colors according to the brightness level. So the thing that seems to be funking out right now is that if digital read that, call color change, and color change increments is, no, I don't want color change. If digital read is low, call change brightness. So it seems that change brightness is happening regardless of what's happening. It seems to be doing the do without us wanting it to do the do. And why is that? Maybe we can just ask it. We'll just ask it. So, Chatgpt, the code works, but it seems that the brightness seems to constantly cycle from dim to bright. Is there anything in the code that could be causing this? Well, let's see what happens. So, it said that, sorry, it could be the delay function at the bottom, this little guy right here. I'm just curious, if we just go down here and set that to 0 instead, what will change? Oh, it seems to cycle even faster. Still something up with that change brightness function. Okay, I figured it out. It's a hardware problem. I don't particularly know why, but on the DigiSpark, for whatever reason, I was having triple difficulty with pin number 01, pin number 2 for this. Not 2, pin number 1, because P1, because it just would automatically cycle. And so if we look at the pinouts here, it says P2 is used for the LED. It's not listed as an analog pin, so maybe that's part of it. I don't know. I moved it to P3. Maybe that has a difference. You know, there's let's see. Is there any reason why this wouldn't work and why it would work here? I really can't tell why this pin wouldn't work, aside from this one's an ADC pin and this one's just a PWM pin. Whatever. Was I looking at this correctly? Pin 1 and 2. So it's pin 2. So it's P1. Yeah, so it's P1. Yeah, I don't know. But the fix for it was just to move it over to the other pin further down the line and use P3. So Chatgpt actually, the original code, the first one he gave me, works fine. And all of them probably work fine if you just change the pin. So that's Chatgpt in a nutshell. I didn't actually have any problems with it. It's going to take our jobs. But it made an RGB LED for me that I can change the colors and I can change the brightness. And it just works. Check that out. All right, well, that's enough playing around with Chatgpt for tonight. Take care. Subscribe. Something. The system is down. The system is down.